I'm Dr. Sophie, and this is my intern, Willi. Today's lesson will be all about acids, bases,
and dangerous acid-base reactions,
and how to prevent accidents.
What's an acid?
Well, a guy named Savantia Arrhenius defined it as a material that can release a proton, otherwise known as a hydrogen ion. For example, hydrogen chloride, an acid, releases hydrogen ions. Properties of acids. Acids neutralize bases in a neutralization reaction. They taste sour, they corrode active metals, and have a pH of 0 to 6, where 7 is neutral. Lemon, milk, vinegar, black coffee, beer, wine, bananas, and even urine.
Well, then what's a base?
I'm glad you asked. It's actually pretty basic. Anyway, Arrhenius the genius defined it as a material that could donate a hydroxide ion. For example, sodium hydroxide, a base, releases hydroxide ions. Properties of bases. They neutralize acids in a neutralization reaction. They denature protein, and that's why they feel slippery, because they're destroying your flesh. They taste bitter and have pH levels ranging from 8 to 10. Common basic substances: baking soda, soap, bleach, eggs, chalk, and laundry detergents.
Why do we need to know all of this?
Because you'll be exposed to acids and bases wherever you are, whether it's at work, home, school. Remember, bleach, vinegar.
Well, who cares? I mean, it's not gonna kill me if I don't know.
What an intern thing to say. Mixing certain acids and bases without proper dilution or neutralization can be so hazardous. Even fatal! Yeah, so you better care, because these bad mixes can even be done at home. For example, the mixing of chloride bleach with some acidic toilet bowl cleaners can produce a poisonous gas called chlorine gas. High-level exposure to this gas will especially target your respiratory system, and even cause
But can't you fix it?
Well, you sure can prevent it. One thing you can do is dilute your chemicals. Dilution is the process of adding more solvent to a solution in order to lower its concentration. Just like when you add a little bit too much water to your hot chocolate. It tastes bland because you've lowered the concentration of the hot chocolate. It doesn't taste like anything anymore because, you've diluted it. And you can do the same thing with chemicals in the lab. In a laboratory setting, dilution can lower the concentration of the acids and bases you're working with in order to tailor to the needs of the lab, and consequently reduce their harmful effects.
Ooh, can you show me how to do it?
Okay, there are 3 main parts to the dilution process. Step 1. Calculations. For example, you have a 1.0 molar solution of HCl and want to prepare 250 milliliters of 0.2 molar solution of HCl. You can determine how much HCl and water you need for the dilution by doing the calculations. For dilutions, we can use the formula C1 times V1 equals C2 times V2, where C is concentration measured in moles per liter and V is volume measured in liters. First, we're just going to write down everything we know so far. The next step is just to fill everything in and solve for whatever value you're missing. Then find out how much water you need by subtracting V1 from V2. Step 2. Prepare yourself and get ready for the lab. Read over any MSDS sheets to become familiar with the chemicals you're about to use. And don't forget your proper lab attire. Yep, that includes gloves, goggles, the works. Step 3. Perform the dilution. Have the water ready in the flask, and then slowly add some HCl. Always add acid to water. and then slowly stir the contents with a stirring rod. And that's how you perform a dilution. The second way to prevent accidents is through neutralization. A neutralization is basically a double displacement reaction between an acid and a base where a salt and water is formed. When a strong acid and a strong base solution are mixed, a neutralization reaction occurs, and the products do not have the characteristics of either acids or bases. So at the end of it, they've neutralized each other. For example, the neutralization reaction between hydrogen chloride and sodium hydroxide yields sodium chloride and water.
It's almost hard for you to understand. Take this example. Here are the acids. Here are the bases. They switch partners. Kaboom! Here's the salt, here's water.
Neutralization reactions are everywhere. They're used to treat acidic basic soil, treat acidic gas, treat gastric patients, to prevent tooth decay, and even when using shampoo and conditioner. And the main steps to completing a neutralization reaction are pretty much the same as dilution, the biggest difference being the calculations. So I'll just show you guys how to do the calculations since you know how to do the rest. Neutralization calculations. Here's a problem. Calculate the volume of a 0.2 molar potassium hydroxide solution that is needed to neutralize 25 milliliters of a 0.115 molar hydrogen chloride solution. First, write down the balanced chemical equation. Then list the given information. This is really helpful. Next, we're going to find the number of moles of HCl. Use the formula N equals C times V. Once we got that, we can now find the number of moles of potassium hydroxide needed. Now, using the formula V equals N over C, we can find the volume needed to neutralize the acid.
Oh, Willi, you done me, and you bet I felt it. I tried to beat you, but you're so hot that I melted. I fell right through the crack.
And that's how you do neutralization calculations. So acids and bases are everywhere. They've got their industrial uses, like rust removal or paper production, and they're also great at home in stuff like cleaning. However, there are always dangers that come with the handling of acids and bases, such as the harmful mixture of household cleaners, not to mention the harmful environmental consequences. Therefore, it's essential that grand-scale actions are taken in order to ensure safe and responsible usage. So in Canada, we do a bunch of stuff to cover this area. Businesses and schools are expected to provide their employees with WMIS trainings. There are courses online to take, and every employee has a right to know about what they're dealing with. So it's on the employer to educate and inform their employees of what they're dealing with. Our government actually has a bunch of programs put into place that I didn't really know about. One of them is called Health Impacts of Chemicals. It's in partnership with Environment Canada, sets priorities and timelines for risk assessment and management of chemicals of concern. The government is actually planning to spend around $25 million on this project. Another program is called Workplace Chemical Safety, and it mostly deals with WMIS and management of that. And for that program, we're spending around $4 million this year. But a more specific project that Canadians are taking on this year is this liming project in Nova Scotia. So basically, they realized that the acidity levels in the waters in Nova Scotia were becoming a little bit too high, because like acid rain and pollution and all that stuff. As a result, they were driving away the salmon, and basically they just want to get the salmon back by restoring their habitats. And to do this, they're gonna add powdered lime to the water. How does this work? It's actually pretty basic. So lime is a base, and it's just added to the water to neutralize its acidic properties. The Atlantic Salmon Federation are actually taking charge of this. And they're actually going pretty big this time. They're using a helicopter. So yeah. So William, what did you learn today?
Acids and bases,
Well, what about them?
they can neutralize each other, but at the same time can produce hazardous products that may be fatal when mixed. Therefore, proper dilution and neutralization is necessary to prevent accidents and ensure safety.
So, Willi, what's your new favorite book?
My new favorite book is the McGraw-Hill-Ryerson Chemistry 11 textbook. More specifically, Chapter 10 about acids and bases. Yeah! You can find this great read on page 452 and 453. Get it.
What?
Get the text.
Because you know I'm all about the bass, no acid. I'm all about the bass, no acid. I'm all about the bass, no acid. I'm all about the bass, I'm making H2O, but I still need a little acid though. But I'm here to tell you every inch of me is basic from bottom to the top. I hope you like that.